I brought my prop with me, something we use each and every day. We use rather a lot of it. We're told we should drink at least 2 liters of it at a minimum. But the question is, how do I know it's safe? The answer is I don't. I trust that it's safe because the water that we consume here in Britain and in other developed countries is very well regulated and comes as part of a supply chain that has had quite a long time to bed in, to be properly invested in, researched, engineering into technical development, et cetera, et cetera. But that's not true for much of the world. And that's part of the story about the challenge of safe water. I think water is a safety grand challenge. In fact, I think water is a lot of safety grand challenges. And in about 15 minutes, and I've got my timer going here, hopefully it will make an obnoxious noise when I get about to 15, I want to convince you of the same. I'm very passionate about water. I see the world through the lens of water. I think it's one of the great challenges of our time. I'll start by explaining a little bit about global level crisis, but I'll do that very quickly because I suspect that most people in this room understand the basics of climate change plus population change equals a burgeoning water crisis. I'll then introduce something called the International Water Security Network, which is a 5-year Lloyd's Register Foundation-funded project designed to investigate a number of different dimensions of this safety grand challenge. And I'll share as much of that with you in the time I have as I can, in the hopes of piquing your interest, suggesting to you that you too can become a water professional. You too have something to contribute to the challenge of water, safe and secure water services. So the climate change part. We've all seen versions of this. We know that we're in an era of global warming. Warming means energy. Energy helps water pool and move through atmospheric and oceanic systems in different ways. And what that's doing is it's changing the relative availability of surface water and groundwater, and it's changing the timing and volume of precipitation around the world. Here in Western Europe, in the United Kingdom, for most of the United Kingdom, this means we'll get about the same amount of rain as we always have, but it's going to be delivered to us in shorter, sharper shocks, volatile rain events. That matters. It is that most quintessential of British problems, the wrong kind of something. But we're relatively lucky. Much of the rest of the world is going to dry out, and in fact, projections for the Mediterranean basin are truly frightening. Population is also growing. Population growth means more demand for water services. More demand for water services at just the same moment when nature, natural processes, anthropogenic or not, are changing the availability of water. That's a challenge. That's a burgeoning crisis. Much of the world is already experiencing what we call water scarcity, or absolute physical water shortage. They're already using more water than is available in surface sources. They are overdrafting groundwater sources. They're doing all kinds of things to try and make up for water deficits. Fortunately, we're in the largely blue part of the world. But as I think everybody knows, even in the United Kingdom, there's an east-west divide. And there are parts of England east of the Pennine Mountains that are nearly as dry as parts of the desert southwest of the United States. So all is not rosy even here in this green and pleasant and relatively well-watered land. The World Economic Forum every year or so meets and considers what are the biggest risks affecting the world economy. And many of them are about water. Water supply crisis has been named every year in the last 4 or 5 years, and in 2015, arguably 2 kinds of water crisis have been named as top 5 challenges for the world economy. The burgeoning water crisis is not just a physical, natural, environmental crisis, it's also an economic crisis. Without water resources, societies cannot thrive or indeed survive, and economies cannot grow. Now let me introduce you to the International Water Security Network. Almost exactly 36 months ago, and with generous support from the Lloyd's Register Foundation, we did something remarkable. We didn't set up a center because the world has lots of water research centers. What we did was we set up a network of global specialist centers for water research. We linked up with existing pots of expertise around the world. The point of that networking exercise was to bring close water expertise, bring close the kind of research and expertise that is addressing this burgeoning water crisis. 36 months later, I'm delighted to say that we're really finding traction. This network now is not just a network, it's a network of networks. We started out with the yellow drops, which I think you can just about see on that map, at the University of the West of England in Bristol, University of Arizona in the desert southwest of the United States, and Monash, South Africa, in the Republic of South Africa. But we've proliferated. We've developed networks of networks and other kinds of spin-off and leveraged activity in other countries around the world, including China, Nepal, United Arab Emirates, Peru, Chile, and Canada. So there's a lot going on in the last 36 months, of which I'm tremendously proud and tremendously excited. And I sometimes think that possibly Ruth and Eileen and Mel and Natalie probably get a little bit sick of me enthusing about what we've discovered this week and lobbing stuff at you and saying, oh, look, follow this link, you'll see something new that we've done. But I'm going to keep doing that until you tell me to stop. So, what have we been doing? Well, we broke our work up into a number of different kinds of work packages, some of them focusing on water security and water safety challenges in the developing world. We know that after 2 water and sanitation decades and a lot of global level attention to water and sanitation for health, or WASH issues, arguably we're no further ahead than we were when we started. And that's because of population growth, largely. Have improvements been made? Yes, they have. In absolute numbers, we serve more people than ever before, even in traditional developing world contexts. But population growth is outstripping our ability to provide these basic services. Part of the challenge, and I'll be honest with you here, a room full of well-trained engineers, part of the challenge is engineering. Here's why. Traditionally, in water development, in water infrastructure development, there has been a sense that if you build it, all is good. So, well-meaning development professionals will procure engineering expertise, they will go out to country X, they'll build some infrastructure, they'll have a ribbon-cutting ceremony, and then go away. Average lifetime expectancy of those sorts of projects is measured in months, not years. Typically, you go back after a few months, or perhaps a year and a half, and you find that the pump sets don't work, they're broken, nobody has fuel for them, something simple happened and there was no local capacity to manage the pump, or it's been stolen. All kinds of things go wrong, and they go wrong because we have tended not to take care of the soft engineering around the hard engineering, the issues of social, institutional, and economic capacity that is necessary for the security and sustainability of the built things that we put in place to provide water services. We know, those of us working in water and development, that if you match those things together, you tend to get sustainability of projects. And that's what we're trying to do in some of the images here. I'll just say a couple of things about them. The first one, oh, my pointer's not working now. The picture in the upper left shows a failed groundwater collection system that was put in by the Norwegians in a shantytown on the outskirts of Kampala some years ago. We went in and did a little bit of civil engineering, put in new retention walls, did some steps for safety of access. There's that word again, safety. Safety of access. We put a fence around the uphill slope so that animals would not graze, so that we didn't get fecal deposition in the groundwater collection zone, because effectively what's happening here is we're harnessing soil water, not even groundwater. So you have to be quite careful because soil water will be very sensitive to animal fecal waste. And we did a lot of training. We tried to set up value chains so that local residents would find it in their economic, social, as well as water provision interests to maintain and protect these systems. They still work. That was about 4 years ago. So we're doing far better than the average. And I think the magic ingredient is social capacity. In the lower right of the diagram is a new kind of project for us. It's something that I told Ruth and Natalie about a few months ago. My colleague Yanis Yaropoulos runs the Bristol Bioenergy Lab, and some time ago, in a quest to find fuel cells for autonomous vehicles, they happened upon an aha moment. That aha moment was that urine can be turned into energy. Imagine that. Each and every one of us is a power source. Makes you thirsty just thinking about it. Well, you can't produce a great deal of electricity with urine, but you can produce enough to run LED lighting. And in a developing world wash context, that matters a great deal because women experience severe safety risks using facilities like this where there isn't adequate light. Light equals safety in this context. There's that word again, safety. This is a safety grand challenge. So we've been working with Yanis and his team, who are all lab-based scientists, to field test this system. And the last few years, if any of you have been around the music festival circuit, particularly Glastonbury, you'll have seen our installations. Because Glastonbury gives us a wonderful opportunity to do some consciousness raising and actually test these systems at a scale not available in the lab. The next stage of the work, which is co-funded with the Bill and Melinda Gates Foundation and Oxfam, is to take these things out into the field, and as I put it to Yanis, we're going to try and break your kit. Because it's got to be robust, and it's got to be resilient. And of course, it's got to be safe. But we don't just build things. As you heard yesterday from one of our students, Yolandi Skuman, we think about how the natural environment can actually provide water services for us if only we're intelligent enough to realize that the natural environment is tremendously powerful. It provides supply, it provides regulatory services and supporting services, and these things can be harnessed. Sometimes it's as simple as figuring out which plants to put in a watercourse so that you can bioremediate pollution that may be caused by anaerobic decomposition of vegetative mass in a reservoir. That's the system that Yolandi was talking about yesterday. But the result is cleaner water. That's a form of eco-engineering that yields improved water security. And then our colleagues in Arizona are working with partner organizations in Central and South America to think about a number of things, particularly food-water relationships in the Andes, water security indices. How do you measure water security? We think we know what water security would be when we see it, but how would we measure it? How do we know that we've got 10% more of it? And thinking about post-disaster recovery. But all of the information for these sorts of things is out on our exhibition table if you want to find out more. And then some of the work that I'm particularly interested in Bristol is thinking about data and the data we have. Now I'm shifting from the developing world to the developed and sharing with you a realization I made some years ago. Water companies in this country have a heck of a lot of data, but they don't have the capacity to analyze it. So we've been working with water companies to think about how to analyze their data. It involves quite a lot of compilation and stitching together of data sets, separating signal from noise, and then figuring out what is it we need to know. What are the analytical purposes that we're trying to achieve? Again, there's more information outside. So, I'm on 13 and a half minutes, and I'm going to conclude well inside my 15. The challenges of safe and secure water services are many and large. It's not just safety grand challenge, it's safety grand challenges plural. But with the right combinations of hard and soft engineering, people inventing and innovating new ways of making more cleaner water, but also the soft engineering that gives us the social, economic, and regulatory capacity to make them sustainable, we can continue to meet these challenges. Crisis, yes. Opportunity, yes. Very exciting times. Thank you very much.
A minute or two for questions for Chad.
I'm pretty sure it's safe.
Yeah, you're. Well, we'll see in an hour or so. Yeah.
I'll take advantage of the fact. I'll take advantage of the fact that I have the microphone. And forgive me, because I'm not. You're far more aware of the situation in the developing world than I am. But when I was listening to you speak, I was thinking about the tension there is between water as a human right and water as a commercial resource. Now that's more apparent in the UK and developed countries, but is that something that's becoming an issue as water is made available in the developing world as well?
Well, a lot of people will simply point out that, of course, water is a human right in the sense that without it, you don't last very long. So there's a certain obviousness about that. How that lives in law is a much more complicated issue. And we've actually written about this. I can send you stuff to read if you'd like.
Chad, that's great. Thank you very much indeed.